Good morning, everyone. Today, I'm gonna discuss about three-phase balance circuits. So, to begin with, let us first understand what do we mean by a three-phase system. Now, in this, we can see a star connection. There are three phases in this: R, Y, and B. In this, when each winding or each phase is connected to a load, then this system is known as a three-phase system. Now, there are two types of connections, star and delta. Now, to how do we define, how do we differentiate if a system is balanced or unbalanced? So, what is the parameter of assessment? So, now let us first understand that. Now, we see in this first diagram, the star connection, and each winding is connected to a load, and we see that these are identical loads. That means the magnitude of these loads are equal. Now, this is termed as a balanced circuits. Thus, when an equal load is connected to each winding, it is known as balanced system. Now, in this diagram, when an unequal load is connected to a winding, it is termed as an unbalanced circuit. Now in this we see that one of the winding is connected to a 220 ampere load and the other two windings are connected to 10 ampere load individually. Due to this, there is an unbalance in the circuit, thus it is termed as unbalanced circuit. Now let us understand few properties of a three-phase balanced circuit. Now first, what do you mean by a load? A load is any appliance or anything which consumes power, to be precise, active power. Now, for example, the light or any electrical appliances we use at our homes are termed as load. Now, the first property of a three-phase balanced circuit is that the phase voltages or currents are displaced from each other by 120 degrees. That means the phase angle between voltage and current is 120 degrees. Now, in a balanced circuit, there are equal loads. But due to these equal loads, the current flowing through each load is same. Thus, the phase angle between the voltage and current is 120 degrees. Now here, this is a waveform of a three-phase balanced circuit. We see that the angle between phase 1 and 2 is 120 degrees and phase 2 and 3 is 120 degrees. Now, to the next property, how do we understand that no current flows through the neutral? So how do we understand this statement? Now, we have a waveform here where we have three currents, IA, IB, and IC. Now, let us consider a point at 90 degrees. At 90 degrees, IA is I max. That means that the current is maximum. At IB and IC, it is minus 0.5 times of I max. Now, when we add all these currents, IA plus IB plus IC, we get an equivalent of 0. So from this, we can understand that even after removing the neutral, the magnitude of the voltage or current in the circuit remains unchanged or unaffected. Thus, this is a very important application of a balanced circuit. Now, to the third property is that it is observed that the power loss is very low. This is an ideal case to be observed in any electrical appliance or a mechanical appliance. Now, any system is supposed to have some power loss, but in this balanced circuit, it is observed that the power loss is very low. That means P is equal to I square R is very low. Now, since we have learned about balanced circuits, let us understand few properties of an unbalanced circuit. We have learned that unbalanced circuit is that when one of the winding is connected to an unequal load or when the loads are unequal, then the system is unbalanced. Now, in this unbalanced circuit, it is totally opposite to the balanced circuit. And it is how that the phase angle is not 120 degrees. That means the magnitude is different from the balanced circuit. Why do we observe the phase angle is disturbed? Because due to the unequal loads, the current flowing through each load is different. Thus, the phase angle will also differ. Now, a neutral conductor is required in an unbalanced circuit, and we observe few power losses in this type of circuit that we don't observe in balanced circuit. So to wind up, let us summarize what we have learned in this uh, topic. We have learned what is a three-phase system is. We have learned how the system, the balanced or unbalanced uh, circuit are differed on what assessment, that is through the type of load. And we have learned few properties in this balanced and unbalanced circuits. Thank you.